Hi guys! Today we are going to learn more about 10.2, which is Arithmetic Sequence and Series. And yesterday's lesson was about Arithmetic Sequence, and today we're going to learn about Arithmetic Series. So today we're actually going to start with a little story. I think I told you this story maybe in Algebra 2, but I will retell the story. It's probably more like a made-up story because this mathematician Gauss is very smart. But basically the story goes, when Gauss was like 9-year-old, he was so smart and that everything at school was so boring that he would just like goof off. So then his math teacher didn't know how else to discipline him. I guess like he wanted to make Gauss like do busy work. so Gauss can't bother other people. So the thing that teacher gave Gauss to do was add up all the way from 1 to 100. And then the story goes that Gauss came back in a minute and said the answer is 50-50. And the teacher was like, that can't be right. And so he spent some time to add up all the integers. And sure enough, Gauss was right. So how did Gauss find out the answer so quickly, right? And that's basically where arithmetic series began. So if you really look at the question itself, it is an arithmetic sequence, right? 1, 2, 3, all the way to 100. Sorry. It's has a common difference of 1. So this is considered as an arithmetic sequence. So what Gauss realized was the fact that if you relist this sequence, but backwards, so from 100, 99, 98, 1, and add them together, you actually get 100 100s. Okay, so let's say that this is S, and this is then another S, so that what we have is 2 S's, right? And it's a lot easier to adding up 100 100 100s because it's just 100 times 101, which is 10100. But do you see how this one is a sum of the one list and another list, right? So to find the sum of the just one of them, which is this sequence, we have to divide each side by 2, and that's how Gauss came up with 5050. And this can be applied to any other arithmetic series that mathematician found out this equation right here, this formula right here, and this is exactly what we saw. The first term, right, and then the second term. So when you have the sum of those two terms, you multiply by how many terms there were. So in our case, it was 100 terms. But then we have to divide it by 2 because we were actually adding 2 sequences together to make it easier, right? So this is the formula you need to know. And we are going to use it in different examples to see how we can solve some of these problems. All right, the first example. If I rewrite the formula, it was S of n. So this is a partial sum because any infinite series for arithmetic series would be infinity or negative infinity, okay? Was n over 2 a1 plus an. Well, a1 in this case is 211. So we know that. And an, the nth term, is negative 455. But the problem is, we have no idea what n is in this case. So what we have to do is that we will actually have to use another formula that we learned in the previous lesson, which is finding nth term. An nth term was found by using this formula. So let me plug in all the values that I know. Negative 455 is 211 plus, I don't know what n is, but the common difference is, let me just use a calculator, negative 18. Okay, so we find n. I'm just gonna do it all in one go. It says n is 38. So if you solve this equation right here, you get n equal 38. So then, now we can finally use the series formula. So S of 38 is 38 over 2, 211 plus negative 455. So we do that times. So I get negative 4,636. That's what I got. Okay. So you saw how that sometimes you can't just plug it into the series formula. You have to actually utilize the formula from last lesson to find the nth term. Not exactly to find the nth term, but like to find n, for example. Okay. So let's look at the next example. This one says find 19th partial sum. Okay, so that looks like S of 19, and we know that A1 is negative 19. Well, but we don't know what A19 is. So then we have to use that formula again. Negative 19 plus, well, in this case, I know what n is, and then difference is 42. So first we find a 19th term, which is negative 19 plus 18 times 42. 737. Isn't that an airplane model? Okay. So then n is 19 over 2. A1 is negative 19 plus 737. So when I do everything on a calculator. Now Noah will really like this chapter because everything we do it on a calculator. But you do need to know the formula. So that's my answer. Alright, last example I have is with the summation sign because I wanted you to know how to read this. But also this one is a little bit interesting because if you notice here, my first term actually starts of a sub 3, which is third term, right? And then it goes all the way to a of 17, so 17th term. So if you see our series formula, it's always from the first term all the way to the nth term. But now we have to kind of modify this. We need to rethink about this because my third term acts like a first term, but if I just try to plug in the formula, it wouldn't work because n is not 17. So it would work great if I can find actually how many terms are between 3 and 17. And to find n, it's always 17 minus 3 plus 1 because it's a counting number, so you always have to add 1. If you don't believe me, think about it. If I have A1 through A3, you count 1, 2, 3, right? But to find the number, it's 3 minus 1 plus 1. So think about that and then apply it to the bigger number. So my n here is, 15, okay? So we start with finding out my actual n. And then I need to find A3 and A17. So to find A3, we simply plug in 3 into my given equation, which is 7. That's A3. And A17 is when you multiply 17 by 3 and then subtract by 2. So that's 49. So again, I will show you how this formula, so I'm still using the same formula, okay? It's this one, S of n is n over 2, A1 plus AN. But what I want you to see is that my A3 acts like A1, and my A17 acts like the last term in this sequence. But then n needs to be modified by using the counting method. So then I have all the numbers that I need to actually find this series. 7 plus 49. So it's 420, okay? If you don't believe me, what you can do otherwise is that you plug in 3, plug in 4, plug in 5, all the way to 17, add all those numbers, and you still get the same answer. Just longer, right? All right, so I think this is all the kinds of example that you will encounter when you do your textbook homework for today. And your homework assignment is right here. So I tried to pick out all the examples that you might see, but simply if you remember the two formulas, then you'll be good. So let me rewrite. So one is finding nth term. This, okay, and then the other one is finding the series. A1 plus A. But sometimes you might have to use this and then substitute here as you find the series. Okay, that's it for today. I hope you the homework isn't so bad and that you finished the method and assignment. And I will see you tomorrow. Bye.